Hi dear students, welcome to Gita's classes. In this class, we are going to do some more problems, important questions in vector differentiation. So before going to the classes, please remember these formulas. Actually, we have the operator del. The operator del is called defined as I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So this can be operated on either scalar point function or vector point function. So if it is operated on a scalar point function phi, it is called del phi, or it is also called gradient of phi. It gives the normal to the surface. Okay. And in vector, there are two. If the vector point function is f is equal to f1i, f bar is f1i plus f2j plus f3k. We can take dot product as well as cross product. So if you take dot product, then it is called divergence. If you take cross product, it is called curl. Okay. So this is del dot f. This is del cross f. Okay. And one more point you have to remember, if del dot f is equal to 0, that is divergence is 0, then the vector f is said to be solenoidal. The vector is called solenoidal vector. If del cross f is equal to 0, that is if curl f is equal to 0, then f is called irrotational. And one more important point, if the vector f is irrotational, if f bar is irrotational, definitely there exists a function phi such that f bar is equal to del phi. Okay. Phi is called the scalar potential of the vector. Phi is called the scalar potential. So this is very important. The problems what we are going to do in this class are repeated questions which are asked in the previous year university exams. Okay. So show that f bar is equal to, and these kind of questions you can expect for the, definitely there will not be any twists in this unit, all direct questions only. So similar problems you can expect. So please try to understand the concept and practice the problems. Okay. So if you understand the concept, you will be able to do the problems easily. So show that f bar is equal to x plus 3i into I plus y minus 3z into j plus x minus 2z into k is solenoidal. Solenoidal means what? F bar is solenoidal. You have to prove that f bar is solenoidal. That is to prove that del dot f is equal to 0. That is the divergence is 0. So del dot f means if f bar is equal to f1i plus f2j plus f3k. What is del? I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So del dot f is dou f1 by dou x, dou f2 by dou y plus dou f3 by dou z. So here f1 is x plus 3y, f2 is y minus 3z, f3 is x minus 2z. So dou by dou x of x plus 3y plus dou by dou y of y minus 3z plus dou by dou z of x minus 2z. So with respect to 1, partially differentiating with respect to x, we will get 1. Partially differentiating with respect to y, we get 1. And here partially differentiating with respect to z, we get minus 2. So 1 plus 1 minus 2, which is 0. Therefore, f is solenoidal. F bar is solenoidal. Now show that f bar is irrotational. So in the previous problem, solenoidal, so we have taken divergence or dot product. Here cross product. Curl f is equal to 0. You have to prove that del curl f is equal to 0. What is curl f? Del cross f is equal to 0. So let us find out del cross f. Always remember that is the determinant of ijk in the first row, dou by dou x, dou by dou y, dou by dou z, and f1, f2, f3 in the third row. Okay. Expanding, we get this dou by dou y of x plus y, that is 1, and dou by dou z of z plus x. So with respect to z, we have to integrate, differentiate. So again, it is 1. Similarly, j into 1 minus 1 plus k into 1 minus 1, it is 0. Okay. Because del cross f is equal to 0 vector, it is irrotational. F bar is irrotational. Next is show that this vector is irrotational and f bar, find its scalar potential. I told you already, if it is irrotational, definitely you can write f bar as del phi, and we have to find out the function phi. Okay. So first let us prove that it is irrotational. Irrotational means we have to prove that del cross f is equal to 0. With a similar method what we have done in the previous problem, in the same way if we proceed, we can prove that del cross f is equal to 0. So dou by dou y of z squared minus xy, that is just expansion of this determinant. Okay. Then I into minus x plus minus j into everything in the every term, it is 0, therefore it is irrotational. If it is irrotational, if the vector f bar is irrotational, there exists a scalar point function phi such that f bar is equal to del phi. Now we have to find out del phi. How will you find out del phi? Del phi is given as f bar. The given vector f bar can be written as del phi. What is del phi? I into dou phi by dou x plus j into dou phi by dou y plus k into dou phi by dou z is equal to the given vector. F bar is nothing but the given vector. So comparing the corresponding components, here I component of I is dou phi by dou x. Here it is x squared minus yz. So here one point is important, that is dou phi by dou x is equal to x squared minus yz. So by differentiating some function partially with respect to x, we got x squared minus yz, right? By differentiating some function partially with respect to x, we got x squared minus yz. So if we integrate this, phi is equal to, with respect to x, we have to integrate, keeping y and z as constants. Now by integrating, we get x cube by 3 minus xyz plus the constant of integration will be there, no? Actually, what is this? Dou phi by dou x, that is partial differentiation of some function with respect to x. So there is a chance of having another function plus, instead of constant, we are going to write it as f1 of yz, y comma z. That is, there is a chance of having another function of y and z also, because we have differentiated partially with respect to x. So if you have, for example, y plus z or y into z, definitely if when you differentiate partially with respect to x, this will become 0. That is why in the place of constant, we are going to write f1 of y comma z. Similarly, dou phi by dou y is equal to y squared minus zx. So in the place of constant, we write, this is partial differentiation with respect to y. Therefore, in the constant, you can have x comma z. Okay. Similarly, dou phi by dou z is z squared minus xy, and here again f3 of x comma y. So we have three equations now. 3 phi, all are phi only. So we have to combine all the three. Always when you are writing this phi, please remember, now from 1, 2, 3 I have written. How to write? This is like the union of sets. How will you write? From the first set, we write all the elements, right? When you are writing the second set, whatever is not repeated, that only we will keep on adding. Similarly, here also, from the first equation, you write x cube minus 3 minus xyz. Okay, that I have written first. From the second equation, what is the first term? Y cube by 3. It is not there, so I am adding. Plus y cube by 3. Minus xyz is already there, so don't add. Okay. So always remember, first you write all the functions, all the terms you have to write from the first equation. And from the second equation, you have to write the terms which are not repeated. If it is already written, don't repeat it again. Don't write it again. Okay. So x cube by 3 minus xyz plus y cube by 3. This is already there, so I am not writing it again. Similarly, from the next equation, third equation, z cube by 3 and minus xyz is already there, so I am not writing. Plus, here. With now we have not written the constants from 1, 2, 3. So combination of all these functions is possible only for a constant k. It cannot be a function of x, y, z. Okay, x or y or z. Otherwise we will have some more function to be added in the differentiation. That is why these three are possible only if the constant is a constant which is not a function of any x or y or z. Okay, therefore phi is equal to 1 by 3. Combining these three, 1 by 3 into x cube plus y cube plus z cube plus the constant k, which is the required scalar potential. Okay, so when you are writing scalar potential, you write from the first equation, you write all the functions, from second and third without repetition. You have to you keep on adding the functions. Okay, adding the terms. Next is another very important question, repeated question. These kind of questions you can expect. One definite question from r per n. Okay, sometimes del dot, del squared, and r per n into r vector. That also we are going to do one more problem in that. So prove that divergence of grade of r per n. So r per n, always please remember, r is a position vector of any point px comma y comma z. R is a position vector of the point px y z. That is always r bar, r vector is xi plus yj plus zk, and modulus of r vector is r. Okay, it is denoted by r. Therefore, what is r actually? R is equal to root of x squared plus y squared plus z squared. R vector is xi plus yj plus zk. Therefore, r vector is root of x squared plus y squared plus z squared, or r squared, squaring on both sides. R squared is equal to x squared plus y squared plus z squared. Let it be equation number 1. When you differentiate 1 partially with respect to x, we get 2r into, in the left hand side, r is a function of x, y, z. So 2r into dou r by dou x. We are differentiating partially with respect to x. So 2r into dou r by dou x is equal to, in the right hand side it is only 2x. So 2 and 2 will get cancelled. So dou r by dou x is equal to x by r. Similarly, differentiating 1 partially with respect to y, we will get dou r by dou y is equal to y by r. And differentiating partially with respect to z, we get dou r by dou z is equal to z by r. Okay. And these kind of r per n problems, up to here it is a must. You have to repeat these steps. You have to write r bar, then r vector, modulus of r vector is r. So r squared is equal to x squared plus y squared plus z squared. And dou r by x, dou x is x by r, dou r by dou y is y by r, and dou r by dou z is z by r. Okay. And grade of r per n. What is asked? Divergence of grade of r per n. So gradient of r per n means I into dou by dou x of r per n plus j into dou by dou y of r per n plus k into dou by dou z of r per n. Gradient means del. That is del of r per n. Okay. So that is I into. Now you have to differentiate r per n partially with respect to x. That means n into r per n minus 1, and we know that r is a function of x, y, z. Therefore, dou r by dou x. Okay. Plus j into, similarly you can write whatever we are writing for this, the same thing will be repeated with respect to y and z in the second and third terms respectively. So n into r per n minus 1 is common. So I into x by r plus j into y by r plus k into z by r. What is this? Gradient of r per n. Gradient of r per n is 1 r. I can, in the all the three terms I have r in the denominator. I can take it outside. So r per n minus 1 will become r per n minus 2. So gradient of r per n is n into r per n minus 2 into xi plus yj plus zk. Okay. Now divergence of, now we have one vector. This is f1i plus f2j plus f3k form. Okay, every term we have n into r per n minus 2 also. So divergence of gradient of r per n is I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot n into this gradient of r per n. That is, divergence means del dot. Okay, del dot f. Divergence of f means del dot f. So del is I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot. What is gradient of gradient of r per n? Already we have found out to be n into r per n minus 2 into xi plus yj plus zk. So when we are taking the dot product, I dot I is 1. So dou by dou x of n into r per n minus 2 into x. N we can take it outside. It is not a function of x or y or z. So n I can take it outside. So dou by dou x of r per n minus 2 into x plus dou by dou y of r per n minus 2 into y plus dou by dou z of r per n minus 2 into z. By taking the dot product we get this. Now consider the first term. Dou by dou x of r per n minus 2 into x. You consider only this term, dou by dou x of r per n minus 2. When we find out for x, the same thing we can write it for y and z. Okay. Similarly, we can write. So dou by dou x of r per n minus 2 into x. Now we know that this is a function of x is also a function of x. So UV form you have to differentiate. So let us take r per n minus 2, you keep it as it is and differentiate x, that is dou x by dou x, which is 1, right? Plus you keep x as it is, so x into differentiate r per n minus 2 partially with respect to x, dou by dou x of. So you have to differentiate r per n minus 2 partially with respect to x. So plus x into n minus 2 into r per n minus 3 into dou r by dou x, because r is a function of x, y, z. Okay. So r per, now differentiate, now simplifying, dou x by dou x it is 1. So r per n minus 2 into 1 plus n minus 2 you keep it as it is, r per n minus 3 into, here we have 1x that I have written here. And what is dou r by dou x? It is x by r. Okay. So that is r per n minus 2 plus n minus 2 into r per n minus 3 into x squared by r. Okay. That can be written as r per n minus 2 plus n minus 2 into r per, this r I can bring it to the numerator. That will become r per n minus 4 into x squared. Okay. So similarly, dou r by dou y of r per n minus 2 into y is equal to r per n minus 2 will be the same plus n minus 2 into r per n minus 4 into y squared. Similarly, with respect to z, if you differentiate partially, we will get z squared. Okay. So combining, now we have to substitute all the values in this divergence of grade of r per n. Then this will become divergence of gradient of r per n is n, we have n here. Okay, in the right hand side we have n here. Okay, n into dou by dou x of, that we are going to substitute. So dou by dou x of this is, here you will get, for x you will get 1 r per n minus 2, for y you will get 1 more, and for z also you will get 1 r per n minus 2, which is common, that's why I am adding all the 3. So it will become 3 into r per n minus 2 plus, this is n minus 2 into r per n minus 4 here. N minus 2 into r per n minus 4 into, for the first term it is x squared plus y squared plus z squared. What is x squared plus y squared plus z squared? It is r squared. Okay. So n into 3 into r per n minus 2 plus n minus 2 into r per n minus 4 into x squared plus y squared plus z squared will become r squared. So this 2 and minus 4 it will become r per n minus 2. That is equal to, you take n inside and n into r per n minus 2 into 3 plus r per n minus 2, I am taking it outside from all the terms. So 3 plus n minus 2 which is 1. That is 3 minus 2 which is 1. So 1 plus n into n plus 1 into r per n minus 2. This is what we have to prove. Okay. Next is similar question, f of r. Show that del squared of f of r is equal to, del squared means divergence of gradient. Okay. So f of r is equal to f double dash of r plus 2 by r into f dash of r. Again here also same thing, you have to take r bar is equal to, in this problem also you have to write all these steps. R bar is a position vector of any point. So r bar is equal to xi plus yj plus zk. Okay. So r modulus of r bar is equal to r, which is equal to root of x squared plus y squared plus z squared. Therefore r is equal to, r squared is equal to x squared plus y squared plus z squared And from this you can write dou r by dou x is equal to x by r. In the previous problem I have explained how to find out all these things. Dou r by dou y is y by r and dou r by dou z is equal to z by r. Okay. So gradient of f of r is equal to I into dou by dou x of f of r plus j into dou by dou y of f of r plus k into dou by dou z of f of r. So f of r means what? We don't know what exactly the function is. In the previous problem we know that r per n. So here we don't know that function f of r. So just we are writing f dash of r into dou r by dou x. Again r is a function of x, y, z. Similarly dou r by dou y and dou r by dou z. What is dou r by dou x? X by r. X by r, y by r and z by r you have to write. So del squared means del squared of f of r is divergence of gradient of f of r. Gradient of f of r we have found out. Just to substitute I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot this function. That is dou by dou x of first function is f dash of r by x by r plus dou by dou y of f dash of r into y by r plus dou by dou z of f dash of r into z by r. Now consider only the first term. I will explain how to differentiate. Similarly we can write it for y and z. Okay. So consider only the first term f dash of r into x by r. So here you have in the numerator I have f dash of r by x and in the denominator r. So denominator is r squared into r into dou by dou x of numerator. Numerator what do we have? F dash of r into x. Okay. Minus f dash of r into x you write as it is into denominator you have to differentiate partially with respect to x, that is dou r by dou x. Okay. Now r into, now let us differentiate this one, dou by dou x of f dash of r into x. Now again product of two functions. So f dash of r into x is f dash of r into differentiating x with respect to x we get 1 plus x you keep it as it is, differentiate f dash of r partially with respect to x we get f double dash of r into dou r by dou x minus f dash of r into x into dou r by dou x is x by r whole divided by r squared. Okay. That is in the denominator it is r squared. In the numerator we have r. You multiply this r inside. Okay. That is r into f dash of r plus r into f double dash of r into x into dou x, dou r by dou x again. Dou r by dou x is x by r. Just a substitution and simplification. Minus f dash of r into x squared by r. So each term we can cancel these things. Here r and in the second term itself r and r will get cancelled. So f dash of r by r plus x squared into f double dash of r by r squared plus f dash of r into x squared by r cube. Now divergence of, this is only for the first term in divergence of gradient. Okay, only the first term we have considered. This is the first term. So similarly now we have second term with respect to y and with respect to z. So wherever you have x squared you have to replace it by y squared and z squared and add everything. So divergence of grade phi is equal to f dash of r by r is common, therefore 3 into f dash of r by r plus f double dash of r by r squared into x squared plus y squared plus z squared, because for the first term we get x squared, second term we get y squared and third term we get z squared minus f dash of r into by r cube into x squared plus y squared plus z squared. We know that x squared plus y squared plus z squared is equal to r squared. So if you substitute r squared will get cancelled. Here again r squared and the denominator we have r cube. So by cancelling we will get r power 1. Okay. So now in the first one we have 3 into f dash of r by r. In the last term we have f dash of r by r. So 3 minus 1 it is 2. So f double dash of r plus 2 into f dash of r by r. This is the function. Now in the question it is not over. In the question what is it given? Also hence find del squared of 1 by r and del squared of log r also. So del squared of 1 by r. So in the place of f of r we have 1 by r. So we let us find out what is the formula? Divergence of grade of r per n. Always remember del squared is divergence of grade, okay, of a scalar point function. So here del squared of 1 by r, it is f of r into f of r is equal to 1 by r. F dash of r is minus 1 by r squared. If it is minus 1 by r squared, again how will you differentiate? If you have r power minus 2, then minus 2 into r power minus 3, right? So minus 2 divided by r cube. Already we have one minus, therefore f double dash of r is equal to 2 by r cube, right? So similarly, now you have to just substitute in this. Del squared of 1 by r is f double dash of r. F double dash of r is what? 2 by r cube. Plus 2 into f dash of r. F dash of r is minus 1 by r squared divided by r. So 2 by r cube minus 2 by r cube, that is 0. Okay. Similarly, for log r also, you can find out f dash of r and f double dash of r. Just to substitute, you will get this answer. Next is prove that it is almost similar to the previous problems only. R per n into r vector is equal to n plus 3. This is a repeated question for university exam. So divergence of r per n into r vector is equal to n plus 3 into r per n. Sometimes they will ask you to prove that for what value of n it is solenoidal. For which value of n the vector will become solenoidal, or it is if it is solenoidal, find the value of n. So n is equal to what? N is equal to minus 3. Okay, if you substitute n is equal to minus 3, this will become 0, right? Then it will become solenoidal. That's what we have to prove. So, and show that r bar by r cube is solenoidal. Okay. So, as usual, r bar is equal to, as I have explained in the previous problems, r bar you have to take r squared, dou r by dou x, dou r by dou y, dou r by dou z. And divergence of r per n into r vector is del dot. Divergence means del dot. Del is what? I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot r per n into xi plus yj plus zk. So dou by dou x of r per n into x. So what will you get? Dou by, first you consider only the first term. Then dou by dou x of r per n into x is, you have product of two functions. So r per n plus x into n into r per n minus 1 into dou r by dou x. So r per n plus x into n into r per n minus 1. This dou r by dou x is x by r we know. So already we have one x. So n into r per n minus 2 into x squared. Similarly, the second term will become y squared, and for the third term we have z squared, and substituting everything in equation number 2 we get divergence of r per n into r is equal to 3 times r per n plus n into r per n minus 2 into the common terms we are taking it outside, and plus into x squared plus y squared plus z squared. What is x squared plus y squared plus z squared? It is r squared we know. So just to substitute, so 3 into r per n plus n into r per n. R per n is common, you take it out, so n plus 3. For what value of this it will be solenoidal? N is equal to minus 3, it will become solenoidal. So if you substitute n is equal to minus 3, then we are getting r per n by r per minus 3 into r vector. That is r vector divided by r cube is solenoidal. Okay, sometimes they will ask you to prove like this, sometimes they will give for what value of n it will become solenoidal. So n is equal to minus 3, it will become 0, divergence will become 0. And show that r per n into r vector, this is the last question, r per n into r vector is an irrotational vector for any value of n. So for the previous question, only for n is equal to minus 3 it is solenoidal. Here for any value of n it is going to be irrotational. Irrotational means what? You have to prove that curl of f is equal to 0. As usual, you take r bar, r squared, dou r by dou x, dou r by dou y, dou r by dou z. Then substitute. Del cross r per n into r vector is equal to ijk, x into r per n, y into r per n, z into r per n. When you substitute and simplify here, dou by dou y of z into r per n. So z is to be, whenever you are differentiating partially with respect to one variable, you have to treat the other variables as constants we know. So here what is there? Dou by dou y of z into r per n. So z you keep it as it is, and only this r per n you have to differentiate partially with respect to y. So n into r per n minus 1 into dou r by dou y minus, here y is a constant because we are differentiating partially with respect to z. So y you can take it outside. Differentiating r per n partially with respect to z, we get n into r per n minus 1 into dou r by dou z. Okay, and we know what is dou r by dou x, dou r by dou y, and dou r by dou z. Substituting, we get these common terms, it will become 0. All the terms it will become 0. Okay. Hence r power n into r bar is irrotational. So these are the important problems. If you practice this, definitely you will be able to clear the exam. At least minimum 15 to 20 marks you will be able to get from these problems. Okay. So please practice, and direct questions, there will not be any twist in these kind of problems. Let us see in the next class with the next unit. Okay. Please give a like and share it with your friends so that it will be useful for them also. And thank you so much for watching.